I'm pretty sure you've seen this error before, and probably this one. There is something common between them. These are cipher suites, which are a list of cryptographic protocols that must be agreed by both ends. In this video, we will have an understanding what are cipher suites and why are they important in establishing the connections. Although SSH and TLS Ciphersuite have similar concept, we will focus only on TLS. On our last video about exploiting Heartbleed, we didn't discuss these concepts, so this will be an extension of that video to further improve your knowledge about TLS. Do note that we will use TLS version 1.2 as an example, as it is still widely used compared to version 1.3. Let's start with this example. I will include the diagram of TLS handshake so we know on which part the ciphers are being used. The negotiation of cipher suites happens on the hello messages. The client sends a list of cipher suites it support. Then the server will choose from the list and respond back to the client. After agreed by both ends, the next steps of the handshake will be carried out. One of these steps is the client key exchange. In this part, client sends the pre-master secret to the server. Take note that this is not the actual secret used to encrypt the messages, but this is just where the master secret will be derived. In order to send the pre-master secret to the server, client will use the cipher they agreed earlier. In this case, client will use RSA as the cryptographic protocol. RSA was named after its inventors. This works by encrypting the pre-master secret using the server public key. Once the server received the ciphertext, it will decrypt it using its private key to recover the pre-master secret. Aside from RSA, different ciphers can also be used. Each has its own security strength. After the pre-master secret was securely transferred to the other side, change cipher spec steps will happen. In a nutshell, this is the part where the cipher will change from asymmetric to symmetric. But there is more things happening behind the scenes. On the earlier slide, we know that the master secret is derived from the pre-master secret. The master secret is then expanded to a key block. The algorithm used is similar on how master secret was derived, but the only difference is the label used. Once the key block is derived, it will be broken down into 6 separate keys. The first 2 will be the client and server write MAC keys. Aside from encrypting the messages, TLS also needs a way to verify the integrity to make sure they are not tampered during transit. Hashed message authentication code is used to do that. A MAC is derived by sending both message and key into a one-way function. The keys used are the client and server write MAC keys. The MAC algorithm used in this case is SHA-256. The next 4 keys are the one used for the actual message encryption. In this example, we are using 128-bit advanced encryption standard operating in cipher block chaining. To be more specific, it operates in a chaining fashion. The initialization vectors used are the last 2 keys, and the secret keys passed to the block cipher are the 3rd and 4th keys. In summary, the first part of the cipher suite definition is the crypto algorithm used for delivering the pre-master secret. The middle part is used for the actual message encryption. The last will be for message integrity. This format is similar on other cipher suite. If you forgot the format, there is a handy tool that you can use. That is by going to Ciphersuite info. Let's try pasting the cipher suite we just discussed. We can see here that it is flagged as a weak cipher suite. Modern secure alternatives typically consist of elliptic curve Diffie-Hellman for key exchange. We can discuss this more on a separate video. Scrolling down, we see the different parts. These are just the same as what we discussed on the slides, but it added another part, which is authentication. We didn't discuss this because this is optional. In some environments that needs tighter security, mutual TLS is used. This means the client will also have its own certificate. In this scenario, client and server will verify the identity of each other using RSA. RSA can also be used for authentication and not only for asymmetric encryption. If we go to the list of all cipher suites, it will show us the different weak and strong ciphers. We can also filter the list by level of security, TLS version, and the libraries that supports it. Let's have a look at an example of weak cipher suite. This says that it is using Diffie-Hellman, which doesn't provide perfect forward secrecy. That means the session keys used in encrypting the messages are static. If an attacker gets hold of those session keys, then the past and future TLS communication can be decrypted by an attacker. Heartbleed vulnerability is also one of the reasons why perfect forward secrecy gained more attraction. As we saw from our exploit video, an attacker can get the content of nearby memory regions, which will include the session keys. With perfect forward secrecy, even if attacker gets hold of a session key, it will only be valid for that particular TLS session. Next is a weakness against the mode of operation used, which is cipher block chaining. From the diagram on the previous slide, we see that the blocks are chained together via different inputs. This can be exploited in lower versions of TLS by allowing attackers to predict the initialization vectors between blocks and uncover the plaintext. This weak cipher also uses DES, which is a broken algorithm in today's standard. DES uses a 56-bit key, which can easily crack within 1 week using a high-end GPU. One last thing before we leave this site. If you notice, there is also a hex code indicator here. This is the value that will be used by the server hello packet in determining the chosen Ciphersuite. This is useful if you are developing low-level exploits against TLS. There are also command line alternatives to check information about a Ciphersuite. For example, we can use OpenSSL to list all Ciphersuites it support. We can also filter by encryption strength. If you want to see the supported Ciphersuite of a website, there is a handy nmap script we can use. This script tries different Ciphersuite against a host and checks whether it will be rejected or not. Let's try to run this and wait for a bit. From the output, we can see the different grades. A is the highest and F is the lowest. This script also shows information on the vulnerabilities and attacks that can be carried out. Let's recap some of the learnings from this video. A Ciphersuite consists of 3 parts: ciphers used for key exchange, for message encryption, and message integrity. There are different keys involved in TLS handshake. First, a pre-master secret is transferred securely. Then a master secret will be derived from it. Then another 6 keys will be derived from the master secret. There are tools we can use to check the information about a Ciphersuite, such as the strength. I hope you learned something from this short video. Thanks for joining me and see you on the next one.